Class 8 Science Chapter 12 Friction, and in this video we will discuss about force of friction, factors affecting friction, static friction and sliding friction. First of all, we will discuss some common experiences from our daily life. A driver of a car or a truck slows down the vehicle by applying brakes at a traffic signal. You slow down your bicycle whenever needed by applying brakes. Why a vehicle slows down when brakes are applied? In this chapter, we will discuss the answer of this question. Let us see some more observations. Any object moving over the surface of another object slows down when no external force is applied on it. Finally, it stops. Moving ball on the ground stops after some time. We slip when we step on a banana peel, like this. It is difficult to walk on a smooth and wet floor. Behind all these experiences and observation, a force is working, and that is called force of friction. Now we will discuss what is this force of friction. There is one activity. Gently push a book on a table. This is the book kept on table and we are pushing this into this direction. What happens? We observe that it stops after moving for some distance. Now book has covered distance from this to this. Okay. Now push the book from the opposite direction. Now we are pushing the book from this direction. Again observe what happens. You will observe that it stops after moving some distance. That is, book again stops like this. This distance is covered by the book. Now question arises, why? A force is acting on the book opposing its motion, and this force is called the force of friction. The force of friction always opposes the applied force. You can say that if motion is in this direction, then force of friction is applying opposite to this motion, that is in this direction. Okay, and the force of friction acts between the surface of the book and the surface of the table. That's why this stops after covering some distance. Factors affecting friction. Let us see one activity. Tie a string. String means tar around a brick. Like this is the brick and this is a string. Pull the brick by a spring balance. This is a spring balance. With the help of this hook, this brick can be pulled towards this direction. Okay. Note down the reading on the spring balance when the brick just begins to move. It gives a measure of the force of friction between the surface of the brick and the floor. Now wrap a piece of polythene around the brick and repeat the activity. And again note down the reading in the spring balance. You will observe that this time reading of the spring balance is less. It means less force of friction is acting. Now one more activity. Make an inclined means झुका हुआ, plane on a smooth floor or on a table. We may use a wooden board supported by bricks or books. You can see this diagram. This is one table, this is a wooden board, and with the help of these books, we make it inclined. Okay. Put a mark with a pen at any point A on the inclined plane. Now this is the mark. This is mark A. Now let a pencil shell move down from this point. Now we will keep one pencil shell here and let it move down and observe what happens. Note down the distance covered on the table before coming to rest. Now you will observe that this pencil shall move on this table and you note down this distance. Okay. Repeat this activity by spreading a piece of cloth over the table and a thin layer of sand over the table one by one. It means we repeat the activity by placing the piece of cloth over the table like this. And again note down the distance from this to this. Okay. And then in next part we replace this cloth and we will put thin layer of sand. And again we'll note down the distance. Then we will observe that distance covered by the cell is maximum in case of when surface of table is there. That is no cloth and no sand is there. When we put cloth cover over the table, then distance covered by the cell is less. And when we put a thin layer of sand over the table, again distance covered becomes further less. Okay. Now from these activities, we can conclude that the distance covered depend on the nature of the surface. Okay. Now this nature of the surface, this may be rough or this may be smooth. If smooth surface is there, distance covered is more. Okay. On which the cell moves and also on the smoothness of the surface of the cell. Friction is caused by the irregularities on the two surfaces in contact. Even those surfaces which appear very smooth have a large number of minute irregularities on them. Irregularities on the two surfaces lock into one another. When we attempt to move any surface, we have to apply a force to overcome interlocking. You can see this diagram. This is a table and this is a smooth surface and this is a book. You can see these are the irregularities on the surface of table and these are the irregularities on the surface of book. They interlock. That's why if we want to move the book, we have to apply the force to overcome this interlocking. On rough surfaces, there are a large number of irregularities. So the force of friction is greater if a rough surface is involved. Okay. Friction is caused by the interlocking of irregularities in two surfaces. The force of friction will increase if the two surfaces are pressed harder. Now let us see one experience. You can experience it by dragging a mat when nobody is sitting on it and when a person is sitting on it. Now this is the only single mat is there. Nobody sitting on it, and if you want to drag it, we have to apply less force of friction. Okay, we experience the less force of friction and this mat can easily be dragged. But when a person is sitting on that, what happens? In that case, we have to apply the more force to overcome the more force of friction. Okay. Actually, in this, the mat and floor are pressed together harder. Okay. That's why we have to apply the more force because more force of friction is working. Static friction and sliding friction. What is easier? To move the box from rest or to move it when it is already in motion? You will observe that it is easier to move the box already in motion than to get it started. The force required to overcome friction at the instant an object starts moving from rest is a measure of static friction, and the force required to keep the object moving with the same speed is a measure of sliding friction. Simply we can say, if we move the object from rest, then whatever the force we are applying, that is a measure of static friction. But when object is moving and to maintain the same speed,
Then whatever the force we require, that is measure of sliding friction. And again, if we observe that sliding friction is smaller than static friction, question arises why? Its answer is when the box starts sliding, the contact points on its surface do not get enough time to lock into the contact points on the floor. So, the sliding friction is slightly smaller than the static friction. Okay, student? Thank you.